Okay. Yesterday, we talked about graphing our parabola and finding the roots or the solutions or the x-intercepts or the zeros by looking at where it intersected the x-axis. But Amelia said, you remember what you said yesterday? Okay, we could just set it equal to 0 and then factor. That's what you like to call unfoiling. Okay. So like this problem right here, find the solutions to y equals x squared plus 3x minus 10. Oh, okay. So I'm going to set this equal to 0.
No, please continue.
Hey, I am trying to teach right now. Just stop. Did I say Peyton? You said something? Did I say Peyton?
You looked right at me.
I looked at a lot of people. Gavin, what does this factor to? What multiplies to negative 10 and adds to positive 3? Well, one's a minus, one's a plus. Oh, good. Okay. 5 times negative 2 is negative 10. 5 plus negative. Can we stop and just pay attention? Okay, so now that I have it factored, what did we do with those? X plus 5 equals 0. X minus 2 equals 0. So we got x equals negative 5 and x equals positive 2. That feel familiar? See? Okay. Your job right now. Number 1, number 5, number 7, number 9. You need to find me the solution to those 4. Huh.
What? No, we didn't. No, we didn't. We didn't do this. Yeah. That's the spirit.
Are we only doing number 1?
The ones I highlighted.
Oh, that's cute. Whoa, that's great. Oh, that was a bean.
Exactly. Yes. Yes.
Sorry. Ads. You guys get negative 3, negative 1. That's fine. 3, 7. And then negative 5. Negative 3, negative. And then 7. Yeah, negative 3, negative 5. So you have to make it equal to 0. Yeah. Oh, yeah. Yeah. Right. We're getting 17 times 5. No, what is it? What do you mean? 7? I don't know how you're getting for the math. Yeah. I thought you were getting that like. Well, 7 times 5. I don't know. 5 times 10. Leave my yard on. That's my.
All right. Did you find these to be familiar?
No. Yes. Just a little.
Oh, that's
No,
very
not
interesting.
really.
I'm pretty sure I took that from you yesterday,
It rolled.
and I took it. So you grabbed something off of my desk, but it was in my possession. Okay, did these feel familiar?
Yeah. We did these on the board.
Just a little.
These were the 4 from our warm-up. So we already knew that this factor to x plus 3 times x plus 1. So our solutions, Amy, are -3 and -1. Okay. We already talked about how this number 5 factors to x minus 7 and x minus 3. So when we set each of these equal to 0, I had somebody knock their head the other day by doing that. Can we stay on all fours? Thanks.
Don't name any names, but who was it?
Number 7. We already talked about how this factors to x plus 5 times x plus 5. So what happens when you set these equal to 0? What do you get? You get -5 twice. So you only have to write one of them. Raise your hand if you can describe to me what this looks like on the graph. This is a parabola. X squared plus 10x plus 25 is a parabola. Intersection where?
At the same place. Number 5.
One solution.
Yeah.
So the vertex is at -5. Since both intercepts are at the same place, that means that's where the vertex is. Okay? Yes. Okay, in number 9. This is the one we talked about. Hey, people, there's a GCF. Factor out the GCF. Left over is x minus 8. So if we set each of these equal to 0, we get x equals 0 and +8. You still need 2 solutions here. Some of you forgot about x equals 0. Yep, sure will. Okay.
Why is it?
How are you using this in real life?
Oh, okay.
Exactly.
Okay, please go to the next page. So a lot of these things that I'm teaching you are building blocks to what you're going to learn in higher level math classes that are going to be a little bit more applicable. But right now we need like the foundational skills. So I don't know what you're going to do with your life. So I can't tell you exactly how you're going to use this, but you need this foundation so you can learn higher level math in case you want to do something with your life involving a little bit of algebra.
I'm gonna work on my girl.
Okay,
That's my dream.
I want you to look at number 17. And I don't want there to be any side conversations right now. We have a problem. Say that louder. It equals 21 instead of 0. So what shall we do?
I don't know.
Subtract 21 from both sides Oh.
They were in here for something.
I didn't do anything. No one cared.
Okay, I'm gonna start writing up names of people who are gonna spend some time with me after school because they can't figure out how to shut their mouths while I'm trying to teach. I've already heard 3 people not even know where we are in the packet. We have 2 weeks of school left. In 2 weeks, you can be crazy. You still have a chapter test that you don't get corrections on. So maybe paying attention would be a good idea. Some of your quizzes didn't go so well because you're not paying attention and you're not doing homework. So here's your opportunity to show me that you actually belong going to geometry. And I don't need to have you retake algebra. Hello? Or I need it back though. Okay, so now that we have our equation set equal to 0, now we can do our factoring. I need 2 numbers that multiply to -21 and add to +4, Kane. X plus 7, X minus 3, do you agree? Okay. So when we set these equal to 0, we get -7 and +3. I give you 2 minutes to do the 4 that I highlighted right here. I do not mind if you consult your elbow partner, but this is not social time. This is not screwing around time. This is, we're doing math and we're comparing our answers. Okay, let's look at number 18. Okay, if we set this equal to 0, do you agree with the blue equation I have up here?
Yeah.
Okay, so Reagan, what did you factor this to?
I didn't know.
I need two numbers that multiply to -45 and add to -4. Okay, so let's think of some numbers that multiply to 45. It's divisible by 5, right? 5 and 9. Okay, so if we have 5 and 9, and one of them needs to be negative because of this negative, right?
Yeah.
So if we add -9 and +5, what's -9 plus +5? Ah, -4. Look at that. Okay. So if we set these equal to 0, our answers are -5 and 9. Okay. Make sure you write this out and then you set them equal to 0. Some of you trying to skip from here to here and you're getting your signs messed up. Okay. Okay, in number 19, you need to move that 7x over, and now we have this. Okay, Jaya, what is this factor to? Okay, so we need two numbers that multiply to -64 and add to -12. So off the top of your head, what are two numbers that multiply to 64? Thank you, Jaya. Okay, so since this is negative, one of them needs to be negative, one of them needs to be positive. Is 8 and 8 going to be our answer?
No.
Okay, so Jaya, instead of 8 times 8, okay, I'm really trying to talk to Jaya right now. Okay, 16 and what? 4. Which one needs to be negative? Because 16x. Oh, right here.
Yeah.
We had to subtract the 7x.
I just added it.
Yep. Since it's positive, we need to subtract it over. Okay. So we get x equals -4 and x equals a +16 for our two zeros. This is where this parabola is crossing the x-axis. Opening up. Okay. All right. Now here in 21, this was not set equal to 0. So I took 28x. Since it's positive, I subtracted it over. Okay. What strategy is going to become helpful here? Abby?
Knowing your multiples and that.
Okay, so what am I looking for? There is a greatest common factor of 4x, and left over is x minus 7. Thank you. So when we set 4x equal to 0 and x minus 7 equal to 0, we get answers of 0 and 7. Got that?
No, he doesn't. Wait, what?
Since our two factors are 4x and x minus 7. Preston. 4x equals 0. Well, if I want 0 by itself, I'm going to divide that 4 over. The 0 divided by 4? No way. And then here, if I add the 7 over. Okay. Question?
When number 20 be 6.
No, not just 6. Okay, now in number 23, I've gone ahead and I subtracted that 36 over. There is a pattern that you need to remember. What pattern am I referring to?
I don't have good memory.
Difference of squares. A squared minus b squared factors to a plus b times a minus b. So x squared minus 36 is x plus 6 times x minus 6.
I don't know how to name.
Okay, just to make sure we can remember the difference of squares, go back up to number 15. Same page, just up to 15. Is number 15 a difference of squares?
Yeah.
Is 4 a perfect square? Is 81 a perfect square? Yes, so this is gonna factor to 2x plus 9 and 2x minus 9.
Crazy.
So when these get set equal to 0, we get negative 9 over 2 and positive 9 divided by 2. You don't like that? Sorry. Okay. All right. Can you make a note that part of your homework are the odd problems on 22 and 23? That's only part of your homework. And then keep going to 24. We're gonna do 4 together. And then the remainder of your homework is gonna be 26, 27 odds. Okay. So I took 2 assignments, but I cut them in half and put them together.
Ooh,
I know, right?
fancy.
You know me. Okay. But on page 24, we're gonna do some problems together. Okay? Because guess what? We're not always gonna have a coefficient of 1. Okay. So example 1. What in chapter 8 did I tell you to look for first when we factor? A GCF. Is there a GCF? There is a GCF of 3. Left over is x squared plus 3x minus 4. Oh. Now this guy right here that I'm highlighting, that one's pretty nice, right? Can we factor this one?
No.
Yeah.
No.
You don't know anything that multiplies to negative 4 but adds to positive 3? 4 and negative 1. Now, if I set each factor equal to 0, 3 equals 0, x plus 4 equals 0, x minus 1 equals 0. Does this make sense?
No.
No, this doesn't actually give us anything. This is just stretching our graph. Okay? But this is going to give us a negative 4. And this is going to give us a positive 1. Okay? So it is really, really important that you look for a GCF. Okay? Okay, well, what happens? There's not a GCF. And there's a number in front of x squared. We're going to example 3. Okay. All right. So in number 3, is there a GCF? No. So this is where we need to do our factoring, what you like to call unfoil, with some kind of guessing and checking. So first of all, what's the only way to get 2x squared? 2x and x. Okay. Now, we know we need to multiply to negative 5. And when we FOIL our outside and inside, need to add to be 3x. So what are some options that we have to multiply to -5?
2.5. 2.
Or like -5 and 1. Don't get too crazy. They're gonna be integers.
But I like
Okay. So is -5 times 1 -5?
maybe.
Okay. What does this equal right here? -5x. Positive 2x. What do these add up to be?
-3. So you flip that.
Oh, that's so close, isn't it?
Here we go.
All right, flip the negatives. We can do that. So now we have 2x plus 5 equals 0 and x minus 1 equals 0. For this guy right here, we need to subtract the 5 and then divide by 2. Over here, all we got to do is add the 1, and that's not so bad. How about you try example 4? You try example 4. 22 is too big of a number.
Anything over or under 10.
Alright, you said 4.
I would always start with numbers that are closer together. Like you have an option of 2 times 4 and 1 times 8. How about you start with 2 times 4? We only have like 3 minutes left. Okay. Stop. Doing it? You don't want to do any of those? Do that one now? No. Okay, so my suggestion was to start with 4x and 2x. And if you can't get anything to work there, then move to 8x and 1x. Okay? Hey. We're multiplying to a positive 5, but this middle term is negative. What does that tell us?
It's not positive.
Okay. Both of our numbers are need to be negative. Okay. Now, what's the only way to get 5 with integers? Okay, so does the 5 need to multiply to the 2 or the 4?
2.
2.
Times 4 is negative 20x. Negative 1 times 2 is negative 2x. Hey, hey. There it is.
Stop being a hater, team. He's a hater.
If 4x plus 1 equals 0 and 2x minus 5 equals 0, then we add 1 divide by 4, add 5 divide by 2. There they are. Okay, so your homework, the odds from page 22 to 23, the odds from page 26 to 27.